Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and stimulating edition of This Week in Weather. I'm your host, meteorologist DT from WX Risk here in Central Virginia for this Friday, July 3rd, actually. And I can call myself the Captain of Chaos, Colonel Confusion, Commander of Catastrophe. Let's talk about this week in weather. And a lot to talk about here. Oh man, there's so much. It took me so long to put together the presentation. You have no idea. Working on this thing since 9:30. Can't believe it. Anyway, all right, let's get right to it. First, sorry, here we'll start out a picture of my smiling face from Richmond, Virginia. You can reach me on my Twitter page and on my Facebook page, and of course, there's my Verizon email. You want to reach me that way. And we'll start next. We'll take a look. Start with the soil moisture. So we're going to start with the big picture and work our way down to the small picture, and then we'll switch over to the tropics. So there's so much to talk about. Now this is the soil moisture anomaly as of May 31st, and you can generally see that the eastern half of the country was quite wet in terms of the soil moisture, and that was from the very wet spring we had, as you know. And you can see, the cool and wet conditions for pretty much east of the Mississippi River. Now the plains kind of in between there. The Rockies have been kind of dry, Northern California. Now, this is the change here. This is after June 29th, and you can see that the green areas have shrunk significantly. Now, because we had that upper low, we've had two of them over North Carolina and Virginia. We're still quite saturated, especially Southern Virginia. Not so much the D.C. area and Pennsylvania, but Central and Southern Virginia, West Virginia, the Carolinas have been quite wet. And then another saturated area, Wisconsin, Michigan, another one down there by where Cristobal hit in Mississippi and Arkansas. But clearly you can see orange areas which represent, loss of soil moisture developing over portions of the western Corn Belt and in the Plain States, the upper Mississippi Valley, that sort of thing. Even the Ohio Valley is beginning is back to neutral conditions here, where before it was pretty wet. And if we look at the change here in the past 30 days, look at the soil moisture depletion in the last 30 days east of the Rockies. So it's really turning drier here, and you can clearly see the impact of Cristobal right here. Let me call it my marker so you can see. Remember where it hit Louisiana, Arkansas? You can see that little green area right there. That was Cristobal, the impact of it. So here we are a month later. You can still see it on the soil moisture anomalies. Now, we can look at the long-term soil moisture trends here. And this is as of June 27th. And we can see, the blue areas are super saturated and the dark greens are saturated. So, you look at this, you go, okay, everybody's pretty much wet east of the east of the Rockies, really. But in particular, I mean, you can clearly see, the deep south here is pretty wet. And then across the Great Lakes area is pretty wet. But if you look at this from, let's say, back in April or March, the blue areas went all the way back to Montana. So, and throughout the Ohio Valley and the upper Mississippi Valley. So the dark blue areas are clearly shrinking. And now the rainy pattern we've had in the deep south with these fronts stalling pretty far to the south and these large upper lows here, it's been kept over the past few months pretty wet in the southern states. But if you look at the short-term trend, we can see big changes. Now, this is over the last few weeks. Now, that's a very different looking map. I mean, you just compare this, which is the last 3 to 6 months, to this last 3 to 6 weeks. Now you can see that, of course, the upper low here, the big rains we had in Virginia, North Carolina, but New England's turned quite dry, as everybody there will tell you, and so is Minnesota, Dakotas, Nebraska. Iowa's turned dry in the western areas. Indiana, Ohio has turned dry. We're getting drought conditions in Colorado, New Mexico, Texas, Kansas, western Nebraska. So things are definitely drying out here in this pattern. All right, and let's talk about the MGO for a second. Excuse me, ENSO. The La Nina developing. Is it a La Nina? Is it not a La Nina? A lot of controversy going on about that. Now, this is our latest sea surface temperature map. And you get some tropical tidbits. This is July 1st. And we can see where the warm waters are. There's some cooling going on in the Central Atlantic. Not a big deal. Very minor here. And most of this is because of the dust cloud in this area. The dust cloud coming off of here. It cuts down the sunlight, so the water temperatures don't get as much energy, and they drop off a few degrees. Of course, the northwest Atlantic is getting really warm, as you can see. But also notice here the change in the eastern Pacific. Now, the warm water is mostly in the central Pacific here. So at one point, this warm water was all the way to the coast. And now it's really cut back here a little bit. And we can see the implications of that. And of course, in South America, look off the coast of Peru, you can see the La Nina. but it's only in the eastern areas. It's not. It's only here in region 3 and then region 1 2. It's not in 3 and 4. So the La Nina, if it is developing, is only impacting right here, and you'll see why in a minute. But if we look at the change here, the anomaly, look at on the eastern Pacific here. So this is important. We can clearly see that the water temperatures here are definitely cooling, and that could be forcing us back to a negative PDO. Now, a negative PDO is significant because it makes for hotter, drier patterns over the Midwest, and it places a trough in the Northwest Atlantic or New England. And that has implications potentially for the hurricane season. Now, if this trough is very deep, it has a tendency of kicking the hurricanes off the coast. If it's a shallow trough, then and the Bermuda High is strong, it ends up turning up the coast or impacting that way. So this PDO here is potentially a big deal if it actually develops. And we can see the change here in the Atlantic. Again, the last 7 days, the water temperatures dropped off a little bit, half a degree, a quarter of a degree. Not a lot, not a big deal here. But mostly, again, from the dust. So I wanted to point that out to you, that you can see the changes here. All right, now we can see, to go, my next slide is going to be, yeah, this one here. Now we want to look at our ENSO regions here very carefully, very nicely, because we can see the changes. Now this is region 1.2, so we talked about here where that is, off the coast of Peru, and we can see, oops, wrong slide, and we can see that the water temperatures are way down here. So look at the numbers here. We got CPC, this is the blue graph here, minus 1.36. The Australians over 1 degree, so it's quite cold in these areas. But of course, the official area is region 3.4. This is what we look at here to determine whether we're in La Nina or El Nino. And what's happened is that we reached a negative value here of just about 0.6 of a degree at the end of May. Since then, it's gone steadily upward. The temperatures have warmed significantly. And you can see that neutral on the CPC and on the Australians. It's essentially neutral. And the area to the west, which is ENSO region 4, again, so you can show where that is. That's out here almost by Indonesia. Well, almost out by New Guinea on the equatorial Pacific. Region 4, it's actually warmed up significantly. 0.4 of a degree above normal on the CPC site, and 0.3 of a degree above normal on the Australians. So this would definitely, if there's a La Nina, it's definitely east-based La Nina. Now, the cold water here is really strong in the ENSO, but like we just pointed out, 4 is warming up. So the result is that 3.4, which is the official area, that's keeping it neutral, and that's where we are right now. So if you look at just 3.4, you go, okay, it's neutral conditions, but it's not really. I think we have an east-based La Nina developing here. Now, a complication of this is the Indian Ocean. Now, the Indian Ocean here, the Indian Ocean dipole, the IOD, has turned warm again. Back in the winter, it was very warm, then it dropped off to negative again, and then you can see it. But you can see back here in January, it was warmest ever, which is one of the reasons why the fires in Australia was so dry, was so severe, because the warm water in the winter months in the Indian Ocean shuts off the rains in Australia. So now we have another little peak right here. Now, it's not going to last. It doesn't look like it's going to last, but it is 0.4 of a degree, 0.3 of a degree above normal. And what that does is that causes the MJO to have a false signal. And what I mean is this. This is the MJO region, the different 8 regions. So we all familiar with, or some of us may be familiar with the MJO graph, the different sections here. 1, 2, 3, 4, 5, so on and so forth. But if you look on a map, what this looks like is this. If you stretch it out, those are the 1, 2, 3, 4, 5, 6, 7, 8. So look where region 1 and 2 is. It is in the Indian Ocean. You see that? So let me make sure you see exactly what I'm talking about here. There is Indian Ocean 1 and 2. So what happens is, because the warm water is in the Indian Ocean here, it's causing this to become positive because the water temperatures here are so warm. So it's giving off a false reading for the MJO. And if we look at the latest plots, we can see that here's the Japanese on the left, the bottom middle is Canadian, there's the European. You follow the green line, they all keep it in phase 2, which, like I just said, is the Indian Ocean. And the reason why that's important is because if you look at the anomalies in the US in phase 1 and phase 2, it's got a lot of cool temperatures, no real heat, and it's pretty wet over the Midwest and the deep South states, even into Virginia. The problem is, like I said, this is a false signal, so it means we really cannot count on the MJO to give us any clue about the pattern. Now, here's the official CPC forecast, latest one. You can see it gets definitely the hurricane season here. We definitely get La Nina conditions here going into the hurricane season. And this is from the Australians, eight different climate models. And we can see here, there's July in the upper left, Australia in the middle on the right, and then September. And notice all the gray bars get colder and colder as we go into the heart of the hurricane season. And that's not a good sign for the hurricane season. All right, now let's talk about, we have that set up. Let's talk about more regional here for a minute. Now this is the um, uh, rainfall for the past 7 days. It's been pretty dry in Virginia itself. But we've had some decent rains finally in Pennsylvania, New York State with these big thunderstorms and cold fronts which have come through. New England have really gotten pounded. Some of those areas gotten 3 inches of rain, and they really needed it. If you look at the drought maps earlier, you'll see that they were pretty dry. So that was a good rain from Pennsylvania, New York, and New England. And then we also had some very nice rains in southern Illinois, Kentucky, Tennessee, Mississippi, Alabama. And with all that rain, we've had a lot of decently cool temperatures. Notice the deep south here, Tennessee Valley, Kentucky, Arkansas, relative to normal, it's not been that hot at all. Now Florida has been very, very warm. In fact, the June 30th, I think, was the warmest June 30th on record or something like that. I remember reading something like that. Anyway, all right, here's the surface map. And as you can see, not much is going on. We have one front which came through, which is stalled in a west to east direction. It came through, not a lot of cool air in it, but it's got some lower humidity, so it's not too bad. And then we have another front to the north of the Great Lakes in New England, and then the other front coming out of the Canadian Manitoba into the Dakotas, Montana, and Wyoming. Now, what happened was yesterday, you may have seen a lot of talk about a potential heat wave showing up in the plains and even going into the East Coast. And what happened is the models yesterday went bonkers with the heat dome and the heat ridge. So just to show you a distinguishing difference between the two terms, what's the difference between a heat dome and a heat ridge? So you see how the dark red area is like centered, like this is a ridge. It's just a large area above normal heights. And during the summer months, it's centered more in the equator, the southern jet stream, the southern hemisphere, the closer toward the equator. Then in the north, in the wintertime, you have a ridge over western Canada, which brings in cold air. Here, the ridge is a hot ridge, so it's called the heat ridge, and it causes subsidence and suppresses cloud cover. So during June and July and August, when you have a lot of sun, you have very warm temperatures as a general rule, and you end up getting hotter than normal temperatures. So, and you also get, again, lack of rainfall. And when you have a prolonged amount of lack of rainfall, you get positive feedback. The ground gets drier, so the same atmosphere, which at one point was giving you a max temperature of 90, ends up giving you a temperature of 92 or 93 degrees because that extra heat coming up from the ground with the dry soil conditions. So that's why this is important. That's a heat ridge. Now, the image on the right is a heat dome. That is like the top of the mountain where it's centered, and there's a peak right in the middle of it, centered in one location. Now, this was the information, again, this is from June 30th, and there was the GFS on the left-hand side, and the European is on the right-hand side. The operational models for both of these valid around June 9th or June 10th. So the GFS was showing a nice heat ridge with seasonally hot temperatures, a cold front coming down across the Dakotas, Minnesota. The European had a monster heat dome, and the cold front was much further north. So this was getting a lot of meteorologists excited about what was going to happen in July. And if we look at the ensembles, we can see that they kind of supported that. This is the GFS ensemble for June 12th. Now notice here the heat dome is a little further to the west over the Rockies over to Kansas, and we have this trough coming in again across New England, and the European is showing the same sort of thing. The heat dome is bigger and it goes out to Missouri, but again, there's this trough coming into New England and potentially as far south with a cold front into Pennsylvania or Virginia, Ohio, and that would break the heat and ensure that the East Coast would not see the big heat. All the heat would probably be west of the Appalachian Mountains in the Ohio Valley, the Midwest, the Tennessee Valley, that sort of thing. That's what the models were showing back on June 30th. And to show you what the temperatures were like, look at these temperatures in Virginia on the GFS, valid for June 13th, 14th. I mean, unbelievable heat. Again, that was just a model projection. It's probably not going to happen. All right, now let's talk about the current models for today. So this was the European here. This is valid 72 hours. This is after Sunday, July 5. And we can see that there's a general trough. Here's the heat ridge. We can just outline it like this in the dark red. But notice we don't have that here. We have this little bit of a trough here and another trough here. And this is just a weakness in the general atmosphere. So it's seasonally warm. It's not particularly hot. It's not particularly cold. And it's actually allows for a front to be situated across the deep south. And what happens is, on some of the models, the European on on July 6th or 7th has this little upper low right here. See that? And then it becomes a surface low right like this and brings rain to portions of North Carolina, Virginia on July 8th or 9th. And that would be very nice to see because that also implies cooler temperatures. Now the heat ridge is developing very nicely over the plains in the Midwest. You can see that here. But on the East Coast, we got this little thing right there, right in here, which is a low pressure area, July 8th or 9th on the European model. And that's the only real. Now the issue is that a real or is that just a figure of imagination? But if you look at the rainfall, this is for the front. You can see that over the next 10 days, there's not a lot of rain in this weather pattern for much of the Midwest or the East Coast. I mean, you get some rain on the front in Arkansas, Tennessee, Kentucky, but not a lot. Virginia's pretty dry. Now, the southern states, again, because of this overall pattern here, this weakness in the atmosphere, gets a lot of rain with these stalled fronts. The heights aren't very strong, so they're not suppressing thunderstorms. You're getting a lot of humid conditions, 88, 92 degrees, 93 degrees, and you're getting a lot of thunderstorms, and that over 10 days, you end up getting some decent rains in some of these southern states. Not a lot of it, but decent every day. And the GFS does the same thing as the European with the southern low, but a little later. Here's the GFS now. This is July 9th or 10th in the upper left. So let me show you in case you can't see it. Little low pressure area right here. Okay, and we have this stalled front, again, running like this. So the low develops right here, and then look at this, it becomes a little bit of a coastal storm on July 12th. So one of these solutions is probably correct. I don't know if it's going to be July 8th or 9th, or it's going to be July 12th or 13th. But one of these solutions are probably correct. So that's interesting to see. It doesn't look like a tropical storm. It looks like a coastal storm, but something to watch either way. All right. Now later on today, the models begin to back off the heat dome setting up a little bit. Here's the operational GFS. So the image on the left is 222 hours, which is July 11th, and then again July 15th. And you can see the model has a dome here cutting across the plains and Midwest, starting in day 10 and continuing into 11 to 15 day. But the GFS ensemble is not that bullish on it. The heat dome is in the plains and it's over the Rockies. But again, we see this trough coming in after July 11th to 12th across the Great Lakes in New England, which would mean that the East Coast would probably not see the extreme heat. All the big heat would be Missouri, southern Iowa, Nebraska, Kansas, the deep south, that sort of thing. So that's what the GFS was showing this afternoon. And the European model was showing the same sort of thing. The European has this little upper low again right there over Tennessee, which prevents a heat dome from forming. And then by day 10, it's got another trough on the East Coast, so the heat dome is forced to go back to the west. As long as you keep getting these troughs here, the heat dome is going to be forced out here. So that's the thing. So these models earlier, which were showing the heat dome pattern and like really scary looking for heat back here, notice that the trough is gone in the Northeast. Again, an earlier, go back up to here for the big maps. You see here on the European, when it was showing this, and on the GFS, notice there's no trough in the Northeast. It's gone. That's why the heat dome comes east. But these other models are showing it, and the recent ones were showing it as well. So as long as you got that trough there, the heat dome can't come east. The Midwest, yeah, the Delta, yeah, the Plains, the Rockies, not the East Coast. So that trough is saving the East Coast for the time being. Now, this may change. We may come out next week and the models may take the trough away. But right now, it looks like it's staying there. And that prevents the East Coast from seeing the big heat, we think. But that can change, folks. So let's keep that in mind. Let's talk about the tropics a little bit. A very nice tropical wave came off the African coast today. You can see it there in the lower right corner. Again, if you can't see it, let me highlight it for you. There it is. Now, it looks really impressive, and it is for early July. Of course, the dust is still very strong here. And this is a nice image. You can see the intense dust cloud. Now here the dust isn't too bad, but you realize it's monster dust. But this feature is way to the south, and you can see it's underneath the dust cloud. So it has some possibilities it might develop if the dust stays to the north. It might not. It might just die. But this is the second big wave that's come off Africa in the past week. The sea surface temperatures look pretty warm again in the tropical Atlantic all off of Africa. Most of this cooling is because of the dust in this area here. So I think that's temporary. And the temperatures continue to warm here in the Northwest Atlantic Ocean. So that's kind of interesting to see. That could support a stronger Bermuda high as we get later into the season, if that's actually true. Now, one of the reasons why this tropical wave is not going to develop is because we have sinking air. So this is let's look at the upper air map for 1 second. Okay, so this is sinking air, and this is rising air with the blue, with the purple here, and you can see. So as a result, you're getting suppression, and it's crushing the system. So this is all sinking air here. It's not what you want to see. Now, week 1, it's also the same way, but we get to week 2. What happens is all this nice blue stuff, which is rising motion, moves into the Atlantic, the Caribbean, and then eventually towards Africa. So this is a sign that, as we go to the middle of July, things could change quite a bit. And there are other things going on here as well. Hopefully the dust will well, maybe not, depends whether you want this tropical storms or not. But if the dust collapses and the water temperatures warm up a little more, and the sinking air leaves Africa and we get the rising air, things could get off to the races. The moisture here, remains very strong. This is all of June. Look at that, the last 30 days. Large areas of really good rains here. Some places 100, 200 millimeters, 4 to 8 inches of rain. It is well above normal, so that's interesting. And we're seeing here the winds beginning to change on the QBO, the high level winds at 10 millibars above the atmosphere. So just briefly to show you where we are, this is the equator right here. Okay, so we're looking at the equator in the northern areas, and the blue is negative, negative wind, easterly winds, sinking air, getting in from the stratosphere into the troposphere, the top of that. And this downward momentum is often a sign that the tropics are going to get active when you see that happening during the summer months of July. So that's interesting, and that also causes the argument is that the angular momentum changes here. You can see that on the global atmosphere and just the regular AAM. You can see both of these are negative, and when they're negative like this, and they get locked into position like this is often a sign that the tropics are going to become extremely active, because the super active tropical, especially Atlantic, can have implications and have a significant impact on global angular momentum. So there's a sign that something might be happening as we get into mid to late July. So that's another factor. So in addition to that, and we can see how that impacts things. This next slide, let me clear this out. This is, again, rising and sinking motion here, 200 millibar potential anomalies. The sinking air is the brown stuff. That means no storms and good weather. So there it is. But notice Africa is turning green, getting rising motion going on here in week 2. See that? And of course, that matches, where's that system I was looking at? That matches this rising motion developing in week 2. And then if we go beyond that, this is week 3, 10 to 16 day. Again, the green is now moving into the eastern tropical Atlantic, and the brown is moving further into the eastern Pacific. So as this green progresses eastward, we see more and more favorable conditions in the second half of July in the eastern tropical Atlantic, spreading into the central Atlantic. And that's more rain for Africa. All of this green stuff means a lot of rising motion and a lot of rain. And we can see that by taking a look at some of these anomalies. This is next 7 days on the European weekly. Oops, back here. And you can see, where did it go? Yeah, there it is. Next 7 days, you can see very wet conditions here. Now notice that just inland, it's still pretty dry. Okay, but this is still July, folks. But when we move out of July and we look at the next 30 days, and week 2, I'm sorry, we see that now all this brown stuff is now filled in. We're now turning quite wet in southwest Africa, which is where you get your big Cape Verde systems coming off the African coast. Look at the difference between this and this, week 1, week 2. pretty significant. And over the next 30 days, look at the rains in Southwest Africa, way above normal. So this has all sorts of implications for an early start to the Cape Verde season, in my opinion. Get that dust out of the way, rising motion, get the sinking air out of the way in the western Atlantic and the Caribbean basin, and the water temperatures warm up, and we could be off to the races early with the Cape Verde and tropical Atlantic hurricane season. Anyway, that's the forecast and this week in review. I'm meteorologist DT from Weather Risk. Thanks for stopping by, and be sure to catch me over the Twitter page or on the Facebook page.